Hi, I'm Ben Slater, Chief Product Officer at Instaclustr. This is the first of a four-part series on understanding Apache Cassandra. In this video, I'll run you through the basics of Apache Cassandra, the function it performs, and key concepts and terminology. Apache Cassandra is a distributed database designed to provide extremely high levels of availability and virtually unlimited scalability. Cassandra does this by operating as a collection of nodes that are all the same. There's no master with multiple nodes doing any given job. If one fails, then another one just takes over. Here's some of the terminology that we use in Cassandra. A cluster is the highest level grouping with all the nodes working together as a single logical database. Within a cluster, we have data centers. Each data center is a complete copy of the database that Cassandra keeps in sync. Data centers were originally designed and named to map to physical data centers for DR capabilities. Today, they're still used for this purpose, but also commonly for geolocation for low latency and workload separation for analytics.
Within data centers, the cluster is further divided into what are called racks. A rack was a physical rack in a data center, which may have shared a power supply or a switch or those kind of things, and that's sort of a single point of failure for multiple nodes. Cassandra takes racks into account when determining how to replicate data so that the data is replicated across as many likely failure points as possible. Then the last couple of bits of terminology that I wanted to talk about were, first of all, replication factor and replication strategy. So the replication strategy and factor are set as part of the schema when you create a table. Well, in fact, a key space, but applies to tables in Cassandra. They determine how many replicas of data Cassandra will store when you write data into a Cassandra cluster. So often, a fairly typical scenario is a replication factor of 3 per data center. That means when you do a write into Cassandra, the node that originally receives the write will replay that write to multiple other nodes in the cluster so that there are multiple replicas of any piece of data. And then if a node becomes unavailable for whatever reason, the other replicas are able to serve reads for that data. The second key bit of terminology I wanted to talk about was consistency level. Consistency level is a property of a query in Cassandra, and consistency level determines how many replicas that are relevant to the query need to return an answer before the query will have considered to have succeeded. So consistency level of quorum or local quorum are fairly commonly used levels, and that means a clear majority of the replicas within the scope have to return before the query succeeds. So for the example of local quorum, the scope of that is within the data center that's connected to, and if you have a replication factor of 3, 2 replicas have to return before the query has succeeded. By using a quorum consistency level and a replication factor of 3, you're able to achieve strong consistency. So all of your reads reflect all of the writes that occurred beforehand, and also to continue to have availability in the face of one replica becoming unavailable or going down. So one replica, if we're using racks, can mean a single node, or it can mean an entire rack, and the cluster will continue to operate as normal because you still have a quorum level of nodes available.
So that was a basic introduction to Apache Cassandra. In the next video, we'll learn about data model design best practices for Apache Cassandra. For more information, please visit our website, www.instaclustr.com.